Hi everyone. Today we are going to discuss about closest pair problem using divide and conquer approach. We will see how the problem can be solved efficiently using the divide and conquer technique. Let us understand what the closest pair problem means. Suppose we have several points on a two-dimensional plan. Our task is to find the pair of points that are closest to each other. For example, if we have a points P1, P2, P3 and P4, we calculate the distance between different pairs of points and identify the pair having the smallest distance. The distance between two points can be calculated using the Euclidean distance formula. The coordinates of 2 points are x1, y1 and x2, y2. Then the distance is d equal to square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. The main challenge is that the number of points becomes very large. Comparing every possible pair becomes expensive. So the straightforward solution to the closest pair problem is called the brute force approach. In brute force, we compare every point with every other point. If there are n points, the number of pairs that we may need to check is approximately n squared. Therefore, the brute force approach has a time complexity of big O of n squared. Now, let us look at some real world examples. One example is air traffic control. An air traffic controller wants to identify two aircraft that are closest to each other. Those aircraft may be considered possible collision candidates. Another example is postal service. A regional postal service manager may use the location data to analyze nearby post offices and identify candidate locations for closure or reconstructing. So the closest pair problem is not just a theoretical problem. It can be applied to many real world location based problems. The divide and conquer algorithm. Now we move to the main concept of this presentation, which is the divide and conquer approach. That is, instead of comparing every point with every other point, we divide the problem into smaller problems. If the number of points is greater than 3, we divide the point into two subsets. We call these subsets P left and P right. We draw a vertical line through the median of the x coordinates. Approximately half of the points will be on the left side and remaining half will be on the right side. We then solve the closest pair problem recursively for the left subset and recursively for the right subset. After that, we need to check whether there is a closest pair where one point is on the left and another point is on the right. This is the important part of the algorithm. Now let us define the algorithm clearly. The input is a set S containing n points in a two-dimensional plan. Each point has an x coordinate and y coordinate. The output is the distance between two closest points. The most important idea is that we are not necessarily required to return all the points pairs. Our main objective here is to determine the minimum distance between any two points. The divide and conquer method achieves this more efficiently than the brute force approach. Now let us go through the algorithm step by step. In step 1 is divide. We divide the given points into two subsets called S1 and S2. We use a vertical line x equal to m. The line is selected using median x coordinate. The purpose is to make the two subsets approximately equal in size. So the points on the left side of the line are placed in S1 and the points on the right side are placed in S2. In this way, a large problem containing endpoints is converted into two smaller subproblems, each containing approximately n by 2 points. This is the first important step of divide and conquer. In step 2, after dividing the points, we move to step 2. In step 2, we recursively find the closest pair on the left subset S1. Let the minimum distance found on the left side of be D1. Similarly, we recursively find the closest pair on the right subside S2. Let this distance be D2. Now we come to step 3. We calculate D equal to minimum of D1 and D2. So this means that currently D represents the smallest distance we have found within either half. But there is still one important possibility. The closest pair might consist of one point from left side and another point from the right side. Therefore, we cannot simply stop after solving the two halves. We need to examine the points closest to the dividing line. We consider a vertical strip of width 2D, which means a distance D on either side of the dividing line. Only the points inside the strip can potentially form a cross border pair that is closer than D. Now we come to step 4, which is the most important part of the algorithm. We have a vertical strip around the dividing line. We divide the points in this strip into two groups. C1 contains points from the left subset and C2 contains points from the right subset. These points are arranged in increasing order of their y coordinates. For every point P in C1, we check points in C2 that may be closer than the current minimum distance D. The important observation is that we do not need to compare P with every point in C2. According to the algorithm, there can be only a smaller number of relevant points that need to be checked. The observation is what allows the algorithm to achieve an efficient running time. Now we need to understand why we can check only a few points instead of comparing every possible pair. Each side of the dividing line can contain approximately n by 2 points. If we use brute force, we go to every point, we compare every point from the left side with every point from the right side. That would require approximately n by 2 multiplied by n by 2 comparisons, which again becomes quadratic. But the divide and conquer algorithm uses an important geometric observation. After sorting the points according to their coordinate, for each point we only need to check a limited number of following points. The slide explains that only the next few points can possibly be within distance d of the current point. Therefore, instead of checking all the points, we check only a constant number of nearby points. This is the key optimization. So this is the efficient closest pair algorithm. Analyze the efficiency of the closest pair algorithm. We already seen that the brute force method takes order big O of n square time. The divide and conquer method is more efficient. The running time can be represented using the recurrence n equal to 2 into t of n by 2 plus m of n. Let us understand this formula. T of n represents the time required to solve the problem with the n points. 2 into t of n by 2 represents the two recursive subproblems. Since we divide the original problem into two halves, we solve two problems of size n by 2. M of n represents the additional work required to combine the results. According to this, the additional work is big O of n. Therefore, the complete recurrence is T of n equal to 2 into T of n by 2 plus big O of n. So by applying the master theorem, A equal to 2, B equal to 2, D equal to 1. So the final, applying the master theorem gives us final time complexity is big O of n log n. So this is a major improvement compared with the brute force complexity of big O of n. So this was the reference used for this presentation. Thank you.